Okay, I think that the recording has started. Excuse me. But what I wanted to do was make a video that will explain to you guys how to make those graphs. So I know I went over this in class, but it seemed like a lot of people still had questions or could use a reference point for that. So I'm going to try and make this video and hopefully it works out. Before I get started, I do want to note I am using a Windows computer. So if you have a Mac, things might look slightly different on your end. If you have a different version of Windows, I think I've got Windows 11. So if you have like 10 or 7 or 8, things might look different there. Most of it should be pretty straightforward, but just in case that's an issue that you might run into, and if you have any trouble with that, let me know. So what I have on my screen here, which hopefully you're able to see, is essentially just a set of data that I've collected. So you can see I've got my wavelength data and absorbance data for 3 different concentrations of dye. I've done this with red dye number 40. I've made 10 milliliter solutions of that. And in these columns, you can see this one had 4 milliliters of dye, 6 milliliters of water, 3 milliliters of dye, 7 milliliters water, 2 milliliters dye, 8 milliliters water, etc. This is the concentration of the stock solution, and this is the concentration that I've calculated for the solution that I have. So what I made when I combined the stock solution with the water came out to this concentration. I just did that math in the Google Sheet. And then from here, I copied and pasted those values down into this section. Some of them are highlighted in yellow and blue, and I'll tell you why later. But the first thing that I want to do, right now I have this in a Google Sheet. I have this in a Google Sheet because that's really good for sharing. But in order to graph it, I want to put it into Excel. If you don't have Excel, you can download it for free through the University of Minnesota in that really big, giant UV-Vis summary document that I sent you guys. There is the link to that free download, or you can just Google like UMN free Microsoft Office download, and it'll pop up. But for now, I want this in Excel. So what I'm going to do is I'm going to click File, Download, and then Microsoft Excel. And all that that's going to do is take this entire sheet and share it in Microsoft Excel. So I'm going to open that Excel file. And just really quickly, I'm going to stop screen sharing because I have a funny feeling it might not have picked up the Excel file. Okay, so you should be seeing that Excel file now on the screen share. I'm just going to make it full screen. And you can see once I've downloaded it right away, I'm going to hit Enable Editing so that I can actually edit this sheet. So the first thing that I'm going to do is I'm going to say, all right, what if I don't remember what my spectrum looked like? The first thing I want to do is I'm going to make my spectrum. And what I mean by make my spectrum is I'm going to recreate what I saw on the Logger Pro UV-Vis page. So there's that page with the rainbow on it and you got some line. I'm going to recreate that. And you would want to do this for each individual dye, but I'm just going to do it for one for the sake of showing you guys. And so for these wavelength and absorbance values here in my most concentrated solution, that's the table that I'm going to make, or that's the data that I'm going to use to make the spectrum. So I'm in an empty cell right now. I'm going to hit Insert at the top of the page. I'm going to go to Charts, and I'm going to pick the one that's the smooth lines. Okay, obviously what I have right now looks absolutely nothing like what I want, right? It's a couple of random lines. So once you're on the chart, I do this by right-clicking and hitting Select Data. You can also select the chart and go up here, which I think if you're on a Mac, you have to do it this way and hit Select Data. So you can see these things are all of the data that is currently in my chart. Just go ahead and remove them. It's just plugged in random data. So get rid of those because they're not what you want. And then hit Add. And you can type in some series name. So I'm going to type it 4.44 E-05. So I'm going to name it that spectrum. And that's just because this is my concentration here for what I used. In the X values, remember on your X axis, you wanted wavelength, and on your Y axis, you wanted absorbance in your original spectrum. So that's what we're going to put. So I'm just going to scroll all the way back up to the top. And I am going to, again, we want wavelength. I'm going to select all of the data points that are wavelength data points. And there's not a great way to do this. You could hit Control Shift and then the down arrow to select all the data points at once. But in my experience, I found that every time I do that, it just randomly deletes some of the data points. And so I just click and select all the way down. Okay, and it'll slow down when you get towards the bottom. So now I'm at the last data point. And then I'm going to scroll all the way back up to the top because I'm going to do this one more time. So with my Y values, I'm going to delete the data that's already there. And then I want absorbance on my Y-axis. So I'm going to go ahead and select all of those absorbance values, just like I did for the wavelength values for the X-axis. You can see it's slowing down now that it's near the end. So I just select those. Okay, so now I have all of my data inputted, and it types all this in when you start selecting things. And I want to hit OK. And then last time I have to scroll all the way back up to the top. Okay, I guess I can't do that right now. I'm going to hit OK a second time. And now I'm going to scroll all the way back up to the top because that's where my chart is. And I can see over here, this is where my chart is. So I'm going to use this to show you a couple of little things. But from here, I'm going to click on this little plus up in the window. And I'm going to get rid of the grid lines because they're just messy and they're in the way. I'm going to get rid of the legend. I don't need it. I only have one line. And I'm going to add axis titles. And what that will allow me to do is say that on my Y-axis, I have absorbance. Absorbance has arbitrary units, so we don't list them. And then on my X-axis, I have concentration. And that is in molarity. And I already have my chart title here. The only thing that I want to do now to fix this is I want to fix up the scale of these axes, right? This goes from 0 to 400 without really doing anything. So under axes, there's this little arrow here. I'm going to click on the arrow and I'm going to click more options. And I'm going to say that I want my axis to go from 300 to 1100 because that's really all I need. And this upper axis, I want to go from, oh no, where did it go? Okay, so this is a good point. That upper axis, you can click to do different things with your axes along this top. What you want is the one that looks like a little bar graph, axis options, and that will allow you to change the maximum and minimum. I shouldn't have many negative absorbance values. I do have a few over here, but remember the visible region is about 300 to 800, so we don't care about those. So I'm just going to put 0 for my minimum, and for my maximum, 3.5. So the point of doing this, now that we're about done with this chart, is that you can see what your spectrum originally looked like when you took your UV-Vis scan, right? So you just saved all of the data, and this will tell you, if you look in this region, that your maximum for that peak you're looking at for is about 500 nanometers, right? If we're just eyeballing it, we're going to find it exactly later. But by eyeballing it, it looks like it's about 500 nanometers. So I can say, all right, I can tell Excel, okay, I want you to take a maximum between 450 nanometer. This is the wrong axis. That should be wavelength in nanometers. I'm sorry, I was in calibration curve mode. To make your spectrum, you should have absorbance versus wavelength. Absorbance versus concentration is going to come in when you do your calibration curve. So that's the next plot that we're going to make. If you're just recreating what you got out of Logger Pro, it should be wavelength. I apologize for that. Anyway, as I was saying, your maximum is at about 500. So you're going to take the maximum over the range of like 450 to 550, and that will allow you to find your maximum from there. So the reason that I highlighted a bunch of those numbers is because I had done this already, and I knew that this was the maximum between 450 and about 550, all the way down here. Okay, and then in the blue here is my actual maximum. So how did I know that? I told Excel to do it for me. So I'll delete this cell and run it again. If I just type into some empty blank cell, an equal sign, and then in uppercase letters, MAX, max for maximum, and then an opening parenthesis. From there, I select the range of data that I want to take the maximum of. So in our case, that's going to be the absorbance values in the vicinity of the one that looks like it's the highest point. So for me, that was about 450 to 550. So I'm going to select all of those. And it will type them in your cell as a range. I close the parenthesis, and then I hit the enter key, and it tells me which one's the maximum. So now I know my maximum is 0.8257, blah, blah, blah. So I scroll through these data points and I'm like, okay, we're about 0.5, 0.6. Okay, it looks like it's getting bigger, 0.7. Okay, we're at 0.8. We're probably getting pretty close. And I look over here, 0.8257, blah, 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 blah. That is the same number. So that's my maximum. And I know that that occurred at 504.5991219 nanometers at that wavelength. So then at 504.5991219 nanometers, we're for all of the different concentrations of this dye, I know that my maximum should occur at that point, right? So here's 504 nanometers for the 4.4 concentration. Here's 504 nanometers for the 3.3 concentration, 504 nanometers for the 2.2 concentration, right? And these are my values. So I want to use all of these values. So I'm going to copy them, make a new sheet at the bottom of the page, and just stick them right here, right? So now I'm going to make a little note. My maximum wavelength was 504 I'm just going to abbreviate as 599 nanometers. And then I'm going to collect all of the data that I need to plot for my calibration curve. As I said a minute ago, my calibration curve is going to be concentration versus absorbance. And so I want my concentration data and my absorbance data. So okay, and I'll make these a little bit wider so that we can see the values we're working with. So I know that I have this absorbance value and I have this absorbance value, oops, and I have this absorbance value. And I know that those correspond, I just memorized the numbers, but you'll look back at your data and you'll say, okay, this one corresponded to this concentration. So this concentration was 4.4 times 10 to the -5. We cannot enter numbers into Excel in scientific notation in this format because it doesn't recognize them. So to type this number in Excel, the way I do that is I hit the equal sign and then I say 4.4, and then I type a capital E. And what that tells me is times 10 to the negative, or times 10 to whatever power. And the exponent is -5, so I'm going to type a negative. And if it's just one digit, you say 0.5. Right? If I wanted to say to the -10, I would type in 10, 12, or 14, type in 14. We just want 5, so we're going to say -0.5. And I hit enter, and it will put my number in that format. I'm going to do the same thing with the next numbers. Okay, so now I have all of those numbers in scientific format in Excel. I'm going to get rid of this because we won't be using it. And now I have all of my data collected that I'm going to use in my calibration curve. So now I just have to make my calibration curve. So we're going to go very similarly to the last time, but we're going to make a slightly different chart. So I'm going to hit insert. Again, from my scatter plots option, but this time I'm going to select the one that's just dots, no lines connecting the dots, no smooth lines, just the dots, nothing else. Again, I'm going to go into my chart. I'm going to click select data. You can also do that over here. So select data. And this time I don't have to delete anything, nothing auto-populated. So I'm just going to hit add and I'm going to name it red 40 calibration curve. On my x-axis, I want to put concentration. So I'm going to select those 3 values. And on my y-axis, I'm going to delete what's already in here. And I'm going to select my absorbance values. And then I just hit OK. And then you hit OK again. Again, I'm going to remove the grid lines because I don't like them. And I'm going to add some axis titles. So I have Absorbance, again, arbitrary units, you don't need them. And then over here, concentration for real this time in molarity. So you can kind of see these 3 points, these are in a pretty straight line, right? And depending on how your experiment went, you might not have points that are in a perfectly straight line. That's okay. But what I'm going to do now is I'm going to hit this little plus button and I'm going to check the box for trend line. And then I'm going to hit the arrow next to it. I'm going to say more options. And that should pull up all of this on the side. I want to be in the thing with the grid again, trend line options. My trend line should be linear, right? I could make it exponential, but that would be kind of weird. So we're going to make it linear, especially because we want a linear relationship between absorbance and concentration. I also want to set the intercept to 0. Okay, so you'll notice when I hit set intercept, it will create a new line. So set intercept has now created this upper line. I'm going to select the lower line and just hit the delete button on my keyboard to get rid of it, because I only want the one that's set to 0. The reason I want to set it to 0 is because when my concentration is equal to 0, my absorbance should also be equal to 0, right? If there's nothing in my solution to do the absorbing, then my solution should not be absorbing. So we've set the intercept to go through 0. Do not add another data point like 0, 0 into your graph, because that won't put the line through 0. It'll just shift the slope of your line and mess up your data. But if you set it to 0 like this, then you're all good. Also, when I deleted the old line, this box disappeared. All I had to do to get it back was click on the new line that I haven't deleted. From there, you want to click Display Equation on Chart, and that will give you the equation of your line. So I'll make that a little bit bigger. Apparently, I can't make that a little bit bigger, but normally you should be able to adjust that. I have this equation of my line, and I'm also going to go ahead and click Display R squared value on chart. You don't have to do that, but you can if you'd like to. So 2 things about this. What this equation says here, you have y equals 18,580 times x. Well, we know that on the y-axis, we have absorbance, and on the x-axis, we have concentration. So I can go ahead and rewrite this equation in my head as absorbance is equal to 18,580 times concentration. And that is exactly what I can use to figure out the concentration of my unknown. So I will have the absorbance of my unknown, right? I'll have some spectrum with a peak on it. I find the maximum absorbance at that peak, and I do that the same way that I found the maximum in this range on this other sheet over here, right? You look at your plot and you say, okay, the maximum looks like it's about here. You select that data range and you calculate your maximum using this equals max command, and you'll have your maximum absorbance. Plug that in for absorbance and solve for your concentration, and then you're all set. Now, in your lab, you'll have 2 dyes. You're really just going to do these exact same steps 2 times. So I made a calibration curve for red dye. Maybe you'll have another dye. You'll make your calibration curve for that. And that's all you need to do. In your lab reports, you'll need calibration curves for both dyes. You'll need to graph the spectrum of your unknown beverage. And that should, there it is, look something like this, but ideally with 2 peaks. And then you'll be all set. Okay. As always, let me know if you guys have any questions, but hopefully this helps and you can reference it as you are working.